Hello everyone, I'm Luke from SmartCloud's AIoT engineering team, and today we'll be getting started with sound-based projects on the Apollo audio-visual engineering kit. Within Apollo, sound is controlled via ALSA, the Advanced Limit Sound Architecture. Now over ALSA, we're going to be using PyAudio, which is a set of Python bindings for port audio, a C++ library for interfacing with audio drivers. Now on board the Apollo, we have an audio codec and 4 MEMS microphones, which we can control using ALSA and PyAudio. The important thing is to make sure that you've pre-configured your sound card appropriately, and we're going to do just that as seen in the previous video. Let's take a look at getting the microphone and speakers set up on the Apollo. Now, all we have to do is go into the provided Apollo audio project and look at the script run.sh. And here we'll find 2 lines of code, and all we're doing is we are telling which sub-devices on the sound card the microphone and speaker should communicate with. And to run this particular script, all we need to do is type bash and give the address of the script. And we are done setting up the microphone and the speaker. Let's take a look at recording a WAV file using the microphone. What's essential for PyAudio is that we instruct it on the parameters of the recording. We specify a sampling rate, a chunk size, and the time or duration of the recording. You can also decide whether you want to record in stereo or mono by adjusting the number of channels. Now, these parameters are by no means set in stone, and you can definitely adjust them. Time is completely at the discretion of the user. We have found that chunk size being equal to approximately 1/10 of the sampling rate is a good rule of thumb. And ideally, the sampling rate should be kept to within 32 to 64 kilohertz for microphone applications. Now, the process here is relatively straightforward. What we're doing is we are in fact creating a streaming object, which opens the microphone and writes the data to a WAV file, which we play back later on. Now, it's also worth noting that microphones on the Apollo transmit 32-bit data, so be wary of that if you decide to do any processing on an incoming stream. If you want to pass data into an audio AI model, these are typically trained on 16-bit mono audio data streams. So in that case, you would want to flip from 32-bit to 16-bit. And to help you, we have actually provided a function called bitdepth_conversion to do just that. Now, the final matter of PyAudio is that you should specify the audio device you want it to use. The way Apollo is set up is that the microphones and the speaker circuitry are represented sound devices that you can see by running the following command. Over here, we can see all the associated sound cards and sub-devices. Now, if you follow the setup commands from the previous episode or from the run.sh file, and you do not use any external devices such as a USB microphone or something similar, you'll find that the Apollo microphones are represented by entry number 4, or hardware device 1, sub-device 0. And once we know that, we can actually record with the following command. All we need to do is specify our input device, which in our case is represented by integer number 4. And we are now recording, and this is a recording done using the Apollo microphone. Once that's done, you'll find you have a newly created WAV file in the folder WAV files, and it's called smartcloud.wav. Now, let's listen to the WAV file we recorded. We can do this by adjusting the PyAudio class to output audio as opposed to receiving audio. And for that, we can use speaker_wave. Now, in this case, all we are going to do is load a WAV file and write its contents to the streaming agent. We need to specify the sample rate in the script, the WAV file to play, and we need to find the right output device. So once again, if you follow the instructions, all you have to do is type the following commands. Now, as before, the microphone was represented by device number 4. Our speaker is going to be represented by device number 5. So if we want to play the previous WAV file, and we are now recording, and this is a recording done using the Apollo microphone. And there you go. Now, you don't need to use a WAV file every time you want to play sound, because all that's really necessary is an array of numbers. So if we check out speaker_stream.py, we can see an example of generating a sine wave in a script and playing it directly. And in this case, we could actually specify the pitch, volume, and duration. So in this case, we call speaker stream. And I've set some defaults, so all we need to do is specify the output device. The same can be done for the microphone. You don't necessarily have to write to a WAV file, you can process the data directly. However, I would advise keeping programs which are meant to work in real time as simple as possible. Thank you for watching. If you have any questions about anything we've discussed in this video, please feel free to get in touch. We'd love to hear your feedback and if you have any queries. We'll also be releasing more videos shortly, so please subscribe to this channel. In the next video, we'll be going over how to make best use of Apollo's onboard display. Thank you again, and goodbye.